Next, we have Carlos Camardella, telecommunications engineering consultant for Claro.
Okay, thank you, audience. Thank you, Mr. Chris. Thank you, Professor Brito, for the opportunity. I hope my English is not so bad for you to understand. The first challenge to deploying 5G networks is the evolved package core, which is going through the next generation package core for 5G. We are accustomed to regular LTE EPC, which is based on proprietary machines, and we are evolving for the 5G package core, which is based on virtualization and regular IT servers on any kind of data center we would decide to deploy. So So the idea is for supporting this kind of ecosystems, the operators must go through a digital transformation process, which will lead them to a digital service provider, because we need great integration between all the equipments and all the systems which will drive the 5G ecosystems. So integration is the main purpose of all the evolved things that we have in a 5G network. So integration with SDN controllers, with an orchestration system, slice creations, slice selection, and all the services will be decided to curse on the selections. We have to be an integration with all the systems. So it's very difficult to do this in the original scenario of LTE, and for 5G demands big transformation inside the operators. Another thing we might see this, 5G is so easy to decide many things, many technical configurations. Is so granular that turns to be difficult to choose which kind of configuration to be deployed. So you must choose even subcarrier spacing depending on the main service that will be deployed in a neighborhood or in a city. So this demands a very tight project for the 5G networks. This is not so simple as it seems to be. Another thing is interference. We are accustomed to deal with FDD networks, where the interference are not so problematic like 5G in working TDD systems. So when you go through TDD, we will have to choose a kind of configuration for downlink and uplink, which won't let cells which are adjacent to interfere each other. So in TDD, LTE, we will have on 5 configurations for downlink and uplink, and for 5G we have 62 configurations. And there have to be an agreement between operators to choose the configurations that are similar in order to avoid interference. And when you are going to LTE, TDD, you are selecting profiles which are related to subframes, and when we are going to 5G, the profiles are related to OFDM symbols, which is much more difficult to deal with. Another kind of interference is from the sync PTP configurations. Now, for TDD equipment, we need sync probe. We have to sync phase and time, and for FDD only time. When you have to sync phase and time, you have many difficulties we don't have with FDD. So this leads to a very tight sync network. With the easy solution for everything is to have a GNSS configuration at each site equipment that will get to the sync from a GPS system. But not necessarily we can have a GPS at every site. So we have to spread around the network the grandmasters working as a slave configuration to compensate the delays in the whole transmission since the original grandmasters to the place more close to the cell sites, and you have to be grandmasters on the sites. Another problem is the configurations for getting more bandwidth to the terminals, which is nowadays we are using carrier aggregation for 4.5G 4.5 LTE advanced systems. And this works perfect with not much problems, but when we go through to TDD, this causes many problems for syncing. Even comp, it's another problem which is not much deployed in FDD system, but in TDD system it's very difficult to deploy because the main purpose is when we have multipath, the cells must be much closer between them, so we can use cells with a radius so high as we can use on FDD system. So a radius, a cell which will cover 900 meters, we would reduce it to 180 meters if you're using 15 kilohertz subcarrier spacing. If you go to 30 kilohertz subcarrier spacing, it reduces to 90 meters. So it's not a good idea to deploy TDD system with carrier aggregation or comp if we are deploying macro cell sites. It's maybe used for small cell, high deployment of small cells, but for macro sites is not a good idea. Another problem is mobility in high frequencies. We have a small window for transmission the radio frame, so if you are dealing with 2.5 gigahertz, which is the frequency most used for LTE, we have more or less a 10 milliseconds time for transmission the radio frame, which the length of the LTE and the 5G radio frame. But if we are counting mobility around 40 kilometers per hour, the speed of the terminal. But if we go to higher speeds or higher frequencies, for example, 25 gigahertz, with the FR2 range of frequencies, we have, if we maintain the 40 kilometers per hour speed of your mobile terminal, we will have only 1 millisecond to transmit the radio frame. So we will lose 90% of the radio frames. Of course, you can transmit the other radio frames, but with very high bit error rates. So only the first radio subframe will be transmitted without errors, and the others will be massive errors. So it's not interesting to try to deploy mobile system using higher frequencies like FR2, which is above 24 gigahertz. Another problem, which is a Brazilian problem, may have another place in the world, is the interference between satellite transmission for TV receivers in extended C-band and any radio, not 5G or LTE, any radios that is radiating in the band 42 or even below bands, because there's no filtering in the LNBF's equipment that installed in the antennas, in the parabolic antennas. So Anatel and the other operators and radio guys will be on our site in Ilha do Fundão for testing up the equipment and trying to develop new filters to mitigate this problem when the 5G networks will be running. Another thing is how to choose mobile or fixed wireless access depending on the frequency. 3.5 gigahertz, we won't have a lot of bandwidth, a lot of megahertz. So spectrum is much smaller than the higher bandwidth, but we can have up to 400 megahertz or even more. And we have also that mobility problem. So even we can deploy some FWA systems using small cells, but for macro sites, it's not a good idea. But if you are trying to deploy FWA, the ideal condition is to try to get to FR2 frequencies. Thank you, guys.